one's done at least, these are the ones people had ready to go. The questions that are ready to go definitely get priority. So let's go ahead and start it with not randomly highlight. No, number 9. The question that they're asking us to solve, right? We have to take in context. They give you a clue. Sometimes they give you irrelevant. Sometimes I was going to say irrelevant, that did not make sense. Sometimes they give you irrelevant clues, kiddos. So this one is definitely a relevant clue. They tell you the average value is or equals 5. That's an important clue. But then they're asking for the integral. You don't have to solve it by hand necessarily. You just need to figure out what is the value itself. So, kiddos, how can we translate this clue into math? Or how did some of you translate this clue into math? Average value of H. Come on, there's a formula.
1 over B minus A.
Now, why am I going to do D minus C?
Because it's D, C.
That's the interval they gave us. Good. So 1 over B minus A, 1 over D minus C. Keep going.
Integral from C to T, H to X, dx.
Keep going now. Finish the clue.
Equals 5.
Good. So just using the forever card of the average value of H over the interval C to D, plugging into the formula, is 5 equals 5. If they want the integral, I'm pretty sure, kiddos, can't we just multiply? They want that, so what are we going to multiply both sides by? So let's go ahead and multiply D minus C on this side. And multiply D minus C on this side. So which one even closely matches? Ooh, either D or E, and make sure it's oriented the right direction. E should be the correct answer. You guys agree? Cool. Questions on that one? Average value, especially in a multiple choice when you see, or in an FRQ, you see average value. You gotta just jump to that forever card in you. You gotta jump there when you see things. Okay, FRQ number 1. What is given to you in the very, very beginning? Table. Remember, they can give you information 4 ways. Just a table, just a graph, just a function, or words in some combination of the above. Right? I mean, they're almost always words, but table, graph, function, or words. Table. They give you a table, G of X. You gotta make sure you know who's in there. Letter B, estimate the, oh, kiddos, when you see, what should you think? 1 over B minus A, but who's B and A in this one? Okay, so 1 over B, 5, minus A, minus -1. The integral from -1 to 5 of who? Average value of who? G. So G of X. Now what's the dilemma though? Can we just plug and check this to our calculator? Yeah. Why not? Well, yeah, A, it's in the calculator, and B, is there any function to put in the calculator anyway?
No, but doesn't it say using approximation?
So, what approximation that we found in A? The left Riemann sum approximation, of course, and what does that approximate?
The area under the curve.
The integral, right? So when we find the left Riemann sum approximation, we're going to go ahead and plug in that left Riemann sum approximation to approximate the average value. So far I know it's going to be 1 over 6 times
10.
Yep. Where did 10 come from? Just because some people, the left Riemann sum is not their best friend.
You made it into 3 sub-intervals with the length of 2.
Okay, so 3 sub-intervals, we have to like jump every other, right?
Mm-hmm.
Okay. And when we jump, we're trying to think of what our jump is, the base. So what's the jump from -1 to 1? 2. So we have 2 times. And what's the height we're using for the first sub-interval?
8.
The one on the farthest left. So we're using 8. Plus. Okay, what's the distance from 1 to 3?
2.
2. So another 2. And then which one am I using for this sub-interval? Which height?
-2.
-2, right? Because it's the one on the far left. So I'm going to be using -2. And then last but not least, the last sub-interval is also going to be a base of 2 because from 3 to 5. And then for that sub-interval, what am I using?
-1.
-1, the one on the left. So we could technically just copy and paste that and say, sweet, let's just put it down below. Or some of you guys did already figure out that that is 10, so you plugged it in. But just for sake of sticking to the man, and since I graded some BC FRQs, actually quite a few this weekend. Go to Starbucks when I'm supposed to be getting ready for prom, but I didn't have time for that. You guys have fun. Just don't simplify. Please don't simplify. If BC kids can mess up on multiplying and adding, so can EB kids, right? Don't simplify. Please, 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 please. Unless you're trying to check it with an answer key, and so you're simplifying but not writing that answer down unless you're putting it in parentheses and saying I'm not going to write it on the actual AP. Okay, I'm done. Letter C. How is this different? Average value versus average rate. Average G versus average G prime. What do we do? But I can't derive. There's no function. And it's average. Deriving would be instantaneous. Yep. When you see, you think. Except who is my function this time? G. And yes, the AP guys will know the difference between G and F, and they won't like it if you don't. Does that make sense? Cool. So let me go ahead and plug and chug. And how do I find G of 5 and G of -1? I look to the table. G of 5. When X is 5, what is G? When X is -1, what is G? And one more time, what am I begging you not to do? Why? Little baby mistakes happen to the best of us. Or I should say maybe the most experienced. It doesn't necessarily mean best. AKA, if it happens to me, it'll happen to you. Okay, that was it. FRQ number 2, a quick question on C. You were also given what? A table. Guys, they love to give tables and ask you things about theorems and hypotheses with MBT and IBT and EBT and roles is kind of everything. So we give you a table. The table is measuring people. Some of you didn't try this FRQ, that's okay. Just check it out. They gave you a table. It talks about people in line. The DMV, that's rough. Is modeled by the twice differentiable function P, which means P and P prime and P double prime exist. They're continuous. T equals 0 is 7 a.m. 7 a.m. You should start lining up before that. Anyway. Over the time interval, 0 to 12, what is the least number of times that P prime of T is equal to 0? AKA, how many times are guaranteed by a theorem? What's one way that I can know that the rate is equal to 0? At least once for some C. Kind of NVT. What special variation of NVT? Rolls. But if I look at the table, how many times is rolls guaranteed? Once. Why did I draw arrows between that one and that one? F of B equals F of A. F of A equals F of B, because both of the Y values are 25. So, according to rolls, we would say one time. There might be more though. Rolls guarantees one time, but rolls does not disprove anything. Rolls just proves the existence of at least one. Could MVT tell me anything different or anything more than just one? Question, kiddos. MVT has to do with the instantaneous rate inside an interval equaling the average rate over the endpoint. Question, what is the average rate from 0 to 1? Positive or negative? Okay, so MVT, the average, I would say is a positive in the sense of it increases, okay? From 27 to 18, what's the average rate? Positive or negative? Negative, because there's a decrease. Now, I don't know if it's decreasing the entire time. I don't know that. All I know is these separate points. But I do know on average, there's going to be an increase. On average, there's going to be a decrease. On average, what's going to happen next? An increase. On average, there's going to be a decrease. On average, there's going to be an, and on average, there's going to be an, Question. If MVT guarantees at least one positive derivative, negative derivative, positive derivative, negative derivative, positive derivative, positive derivative, how does that help us answer the question, what are the least number of times P prime must be 0? If the directions say a twice differentiable function, meaning P is continuous, P prime is continuous, aka P is differentiable, and P double prime is continuous, aka P is twice differentiable. What do I know? The derivative is going to go from positive to negative at least once between 0 and 2 by MBT. At least once between 1 and 5. At least once between, I guess I should say, 0 to 2, 1 to 5, 2 to 7, 5 to 10, is that right? Or you just count your sign changes and say, hey, I have one sign change, that's 1, that's 2, that's 3, that's 4. So how many times are the least number of times? 4. 4 times. I'm going to do this one. Since an average increase followed by an average decrease on the intervals 0 to 2, MBT guarantees P prime will go from positive to negative at least once. And do a semicolon. And IVT guarantees P prime will equal 0 at least once on this interval. Now if you guys notice, I'm just explaining one, and I'm going to say by similar reasoning, and be able to say this will occur 3 more times on the interval here to here. So I'm taking time to express the one in detail. There's an average increase, average decrease. MBT is going to guarantee that the derivative will then go from positive to negative at least one time, and IVT guarantees P prime equals 0 at least once on this interval since. This is a horrible one, but that's okay. Good thing I'm not creating our grammar. Since P prime is continuous by similar reasoning or similar logic. You don't have to necessarily explain it for every single one. 3 more zeros of free P prime are guaranteed. On, and we just have to get our intervals. So that was 0 to 2, then we have 1 to 5, 2 to 7, 5 to 10. 1 to 5, 2 to 7. 2 to 7, and something to 10. 5 to 10? It was from here to here, here to here, here to here, and here to here. There we go. Because it was every other. To have the average increase and the average decrease, we had to include 3 points. So, the nice thing is, we were very succinct, we were very clear on, hey, our answer is 4. And then we were very clear to show on one interval, just to make things short and sweet and simple, even though it wasn't really that short. We were saying MBT is going to guarantee MBT with IVT. MBT with IVT is going to guarantee from the average increase to the average decrease following the derivative going from positive to negative Since P prime is continuous, yes, there will be a 0. And then we said, okay, sweet. You guys are smart, you know calculus. Or you could tell me, you're smart, you know calculus. You understand by similar reasoning, it'll work 3 more times. Okay, that's good. Kiddos, with that, I think we had one quick question in FR. Ooh, I forgot. You guys had a big old question in FR3. Do we have a table? Yes or no? Yep. What do they give us in the table? A whole lot of stuff. However, it's very important that you see the function f, yeah? It's very important that you see the function f is 2 times g of h of x. Look, I think chain rule is going to come into play. Minus 17. 2 functions, their first derivatives, yada, 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 differentiable. Okay. That means g and h are continuous. If something is differentiable, it's also continuous. And their derivatives are continuous. So, letter A. What did you guys think about when they asked us, must there be a place such that f of c equals 2? Yeah, it sounds like IBT because there's no derivative, right? But the crazy thing is, f is really super complicated. So how do I know f? It's not even in the table.
You plug in.
Plug in what?
So you have to plug in whatever x and h of x, and then you look on the table and you're like, oh, h of x is this. Then you find g of x of the number.
So question, couldn't we expand this table?
No.
Katrina was saying plug in, and she's totally right. I would go a step further, and I would say, okay, fine. From the clues, we should be able to figure out who is f of x and who is f prime of x. True?
Yeah.
Although to find f prime might be a little bit messy because f prime of x is equal to, chain rule, 2 times derivative of the outside, keep the inside, times derivative of the inside, and the derivative of 17 is 0. Okay. So to find f of x, did anybody do this? What did you get for the first function value of f?
I got 0.
Because h of 0 is 1, g of 1 is 8, 2 times 8 is 16, 16 minus 17, negative 1? Is that what you guys said?
Negative 1.
Okay, cool. And then what was f prime?
We have to do
That was a little too scary. Okay. F of 1, if you guys notice, f of 1, I'm taking that 1, I'm plugging it into x. Start with the innermost. So then h of 1 is 3. Plug in 3 to g. G of 3 is negative 2. You're welcome. 2 times negative 2 is negative 4. Negative 4 minus 17 is negative 21. You guys agree? Cool. I'm just double checking. H of 2 is equal to 6. G of 6. That's no fun. Hold on. H of 2 is equal to 6. G of 6 is not on the table.
You basically just need 0, 3 for this entire column.
Oh, must there be. Sorry, 0 to 3. I wasn't even paying attention. Must there be a value? What's 3 then? H of 3 is equal to 2. G of 2 is equal to 11. H of 3 is equal to 2, right? Oh, you already got it. H of 3 is equal to 2. G of 2 is equal to 11. 22 minus 17 is 22.
Wait, I got 5.
22 minus 17. I said that and I wrote 22. Thank you, thank you, thank you. 22 minus 17 is 5.
Yeah, that's kind of how you do it.
So long story short, we can say since since f prime of 1 is equal to negative 21 and f prime of 3 is equal to 5. Sorry, not f prime. Struggle. It's a Monday. Since f of 1 is equal to negative 21 and f of 3 is equal to 5, and f is continuous by, now kiddos, even though you guys are thinking IBT, you have to state IBT. You don't have to write out intermediate value theorem, but you need to state by IBT. By IBT, f of c must be 2 for at least 1 c within 0 to 3. Technically, you could go a little bit further and say 1 to 3. They're not going to count off for that. You've just done one better. Or you could have used f of 0 is negative 1, f of 3 is 5, and saying, hey, yeah, there's a sign change. You probably didn't even have to do f of 1. For letter B, what's going on? Must there be a value D such that? Whenever you see must there be, and then you see an original, think IVT. Whenever you see must there be, and a derivative, think what? MVT. MVT. Well, they say 0 to 3. I bet they told us those points on purpose, right? At 0, I know f of 0. At 2, I know, nope, I don't. Sorry, at 3, I know f of 3. So let's just try MVT and say, I don't know, let's just try it. F prime of D must equal f of B minus f of A all over B minus A. They told us this interval for a reason. I'm just using those points. I have 5 minus negative 1, if I can put the negative in there, all over 3 minus 0. Hey, no way! 6 over 3 is 2. I think they planned this. They did. So therefore I can say by MVT, since f of x is continuous and differentiable, we do it therefore. Therefore, by MVT, since f is continuous and differentiable, there must be at least one value. And guys, you can totally steal their wording to make you sound smart. At least one D within 0 to 3 such that f prime of D equals 2. I already showed y up above with my average value. Yeah.
2 questions. If we were to just do such that as ST, would they get
They
that?
get it. They're good.
And
The only one that they might not get, pips, is only used by some. But if you show the second derivative equal to 0 or D and E, they'll understand what you're talking about. Pips is only used by some, and what else? LH for L'Hopital's, they should be fine on that. KG for keep going, they'll have no clue what you're talking about, but that's okay.
But if you
As long as you show 0 over 0 and then say something about L'Hopital's, like if you were to use L'Hopital's, that should be fine. And any other abbreviation, EVT, MVT, IVT, ST for such that, BTW for by the way, just kidding, don't put that in yours, or LOL. But they should know what most of them are, yeah. DIFF, CONT for continuous. If you have time, go ahead and write everything out, but if not, that's okay. How'd you guys find f prime of 3? Did we already do that? Oh, but we found f prime. Yeah, make sure you guys show f prime of x equals, well, we already showed 2g prime of h times h prime. We just have to plug in 3. So f prime of 3 is 2 times g prime of, remember guys, just plug in where the x is. That's all you gotta do. Times h prime of 3. For my little table, what do we see? H of 3 is, exactly, so I can do 2g prime of 2 times h prime of 3 is 4. So I can do 2 times g prime of 2. It's negative 1. Yes, you should be able to do this multiplication. I have full confidence that normally you would, but your brain at the end of a long AP test, I'm not so sure. Done till I'm done. Kiddos, let's go ahead and pass this up. Odds should be fully attempted. We're not going to have tons of time today, but the nice thing is there's not really tons of notes. It goes straight to problems. Only 2 FRQs, which means only 1 odd one. If I were you guys, I'd go straight to number 1. We don't have a lot of time, so let's just get some problems done. Talk about those maybe tomorrow. Alright, if you were gone on Friday, remember you do have until tomorrow to get this to me, the theorems and hypotheses. Make sure you talk to me and give it to me in person, or else.
Where can I get
Oh, right here. I forgot you came in later. If anybody was gone on Friday, we did turn in derivatives, so go ahead and write absent real quick. I know some of you guys are at Universal. Write absent. I need this one. Any more absent ones for Friday? Or you were absent on Thursday and didn't get it until Friday? kids, you trying number one?
No. Yeah. I don't know.
Yeah, the notes are basically the first derivative test, second derivative test, like all the stuff we know about increasing, decreasing concavity. Alright. What's something someone's figured out?
A is true.
2 is true. I don't know about 2.
Why is 2
Two is false. Because it says must be true. We don't know if it's true. We do know that if you put 1 minus 4 and 6.
Guys, think about your theorems. I have way too many people that are just like chatting and reads. Who knows why? Time is short. AP is close. Spring break is coming. All good things. All good things.
Doesn't that mean
Just
3 also?
why is 1 true?
Because if it's
Differentiable must be continuous.
If F is differentiable, F must be continuous. So I know right now that one's true, so I can cross out that, I can cross out that. Hey, okay. Why, Brandon, is number 2 not guaranteed?
Because we don't know if there's a horizontal tangent.
Yeah, so you can say only guaranteed, I'll just shorten it for right now, only guaranteed if F of negative 2 equaled F of 6. The question, are these two equal? Y values? No. Okay, well then 2 is a no, so I can go ahead, oops, that was yellow. I can go ahead and say, well, again. What about 3? Kiddos, as soon as you see a rate or a derivative equal to a number, what must you think? NVT. And how do you check NVT?
1 minus
F of
4.
6 minus F of negative 2 all over 6 minus negative 2. Is this guaranteed negative 3 over 8?
Yes.
Yes, it is by NVT. Therefore, final answer. Dun, 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 D.
Ew, this is nasty.
2 is false because F of 8 is not equal to F of B, so I don't know for sure that works. Number 3, graphing calculator. Someone, radian mode, in your grapher, graph this puppy and look at the windows 0 to 7. If I had time, I would. Ooh, that
I
goes.
was gonna solve it by hand.
Oh, I don't know.
I wasn't. And stopped
Let's
it.
get to that somewhere.
And just gave up.
The whole thing. Kiddos, I'm going to put a little star by number 3 because he's important because he's having you look at a graph and tell characteristics. But since I don't have a graphing calculator open and time is short, let's go to number 5. Let's not go to number 5, that's graphing calculator. How about number 7? We have the graph of a derivative. We have the graph of a derivative. They're saying, look at 0. We say, okay, cool, there he is, at x equals 0, I have the point 0, 0. Y equals f prime of x. What's going on at 0?
It's a 0.
It's not a local max or min because the sign doesn't change of the derivative. It doesn't go from above to below or below to above. Point of discontinuity. No, it exists. For the derivative, which means the original had to exist. If it's differentiable, it's continuous.
Oh, isn't it
Point
a
of
sharp
inflection
point?
or a vertical tangent line? Which one?
What is it?
Yes, because the slopes of f prime change sign. F is decreasing and then it's increasing, which means f double prime is negative and then positive. Point of inflection is true. Katrina.
But since it's a sharp point, wouldn't that also mean?
Remember 0 or DNE. A sharp point, though, of f prime does not mean that the original had a vertical tangent on it. If the original did, then I would see a vertical asymptote on the derivative instead.
Oh, okay.
Does that make sense?
Yeah, yeah.
Yeah.
Like if it was a double prime graph, it would be like a positive to my positive.
It'd be, hold on. No, because the slope is down, so it'd be below. Because the slope is down, so the second derivative would be negative. And then the slope is above, which means
Not
positive.
there.
So the second derivative graph will go from below to above, but the original graph will go from concave down to concave up. Does that make sense? Alright, cool kids, use those graphing calculators tonight. The odds, but we'll go over questions tomorrow. Just do the best you can, go through quick, 2 minutes every problem. And come tomorrow with what you want. aren't able to get done in that time. You should be able to do at least 2 minutes per problem tonight, okay? Just try your best, get that done. Bye, guys. What's our game plan, Ben?